Irrevocably, we have finally reached the third objective, which is finding the best ammunition. For better understanding, I divided this section into subsections, and as the little prince said, adults love numbers. The best ammunition should be accurate, reasonable, affordable, and the most importantly, reliable. Let's start with reliability. The theory of reliability consists of three factors: contamination, temperature, and design. Contamination always relates to increased frictions, both during recoil and return, which slow down the bolt's movement relative to the round or magazine. Similarly, fouling and dirt in the magazine can affect frictions and feeding speed, causing the round to fail to raise the correct height before the bolt moves forward. And contamination depends on the quality of the dirt. One can recall Sherlock Holmes with his Ziploc bags containing samples of soil from various parts of London, which he used to locate the killer's hideout. Similarly, military tests are conducted in sandstorm conditions with different categories of dirt. For example, large grains of sand may not fit in the gap and therefore won't affect the operation, while very small particles, like fine dust, can get inside but may not be large enough to cause a jam. Intensely fouling and dirt accumulating in the chamber also affect reliability and even accuracy. A case inserted in the chamber sits mostly in the lower part and expands radially to fill the chamber. Therefore, any residues in the chamber or in the bolt will affect the position of the case, and subsequently the detonation and stability is directly related to accuracy. One of the main differences between expensive and cheap rifle is not only barrel quality, but also the precision and chamber and bolt machining. There is a rule in metrology: nothing in the world is absolutely accurate, everything has some margin of error. Hence, high-end and more precise firearms have thicker technical tolerances, and you cannot see this precision with the naked eye. For example, in AK manufacturing, some parts were machined in assembly, because the Soviet level of precision didn't allow the producing millions of components where each one would fit perfectly. In fact, during World War II, magazines from PPSH often didn't fit others, even from the same batch. If you lost a magazine, you basically lost the entire weapon. Thus, in theory, a precision rifle should be as precise as possible, forgive the tautology. But it should be precise in machining of its part, assembly, and overall design. Ideally, there should be no free space between the case and the chamber, and similarly the bolt face gap should be minimal. That's why bench-rest rifles have polished chambers, clean bolt locks, and even checked ejector springs. These things affect accuracy but only in a high level, and that's what sets apart the winners from those who will never be remembered. An ideal system should be perfectly harmonic and balanced. It seems that such systems are bench-rest rifles, the F1 of firearms engineering. But even here we see railguns, a further leap from reality. With railguns, the shifted impact vector caused by bolt group asymmetry is absent, because there is no magazine feed port, but there is a symmetrical side opening to maintain system rigidity. And the scope is installed on rail block for better harmonic stability. It's pure experimentalism, and these are isolated systems, not even rifles anymore. Yet they are only 10% more accurate than bench-rest rifles. Even if everything is perfect, the mere firing pin strike can destroy the system at about 1.1 MOA. But these are laboratory level precision factors, and they hold little practical value for everyday use. For instance, in average rifle with non-match barrel, performing bedding, epoxy, lux polishing, and free-floating the barrel might not even improve accuracy. This is already demonstrated in this video. Returning to reliability, the next factor is temperature. Cold temperatures slow down moving parts, while heat increases movements. Also, cold reduces primary ignition, while heat enhances it. The bolt group may retract so quickly in hot conditions that the next round doesn't raise in time. That is why a K-bolt carrier travels faster than AR-15. Cold frost, much like dust, creates contamination and requires extra energy. Ammunition in freezing temperature changes its chemical properties, losing explosive power.
Вот специфичный звук — это звук от терморасширения. Материал термически тянет, гнет.
But the biggest danger from cold is freezing, and the sudden jerk it creates. Accuracy International began adding grooves to the bolt after Arctic trials. Perfectly smooth bolt will freeze just as perfectly, preventing you from cycling it. These grooves also help with regular dirt, providing space for it to compact when the bolt closes. However, grooves negatively affect accuracy. Asymmetry in the bolt group, oddly enough, provokes similar asymmetrical harmonics. Grooves on a barrel don't help accuracy either. Therefore, a perfectly accurate rifle won't be reliable, and a perfectly reliable rifle won't be accurate. The last factor in reliability is design, when the system is inherently vulnerable, either from the factory or due to tuning.
Okay. There we go. Nope. First round. Notice tangled in. Again. One jam. Feel two. Start still. Head still. Utterly jammed in. And second round. Start deep with an angle lead. Okay. Like that. Go in. Another failure to extract.
One aspect of poor reliability design can lie in the coating or the lack of it. For example, nickel or chrome plating can allow the bolt to move more smoothly within the carrier. Another example of bottleneck in reliability is the design of dust covers. The AR-15's dust cover seals better than the AK's fire selector. This is shown in this video, also in this video, also in this video, also in this video, and many other videos. And the final video, which is the most honest and scientific, also proves and verifies this. Interestingly, the AR-15 manual suggests cleaning the rifle only after shooting, whereas the AK manual recommends clean every day, or at least once a week, even if it hasn't been fired. And yet, the AK has a chrome-lined barrel. How is that possible? Soviet military ammunition uses the cheapest, lowest quality components. For example, military primers contain potassium chloride, also known as bachelor salt. When fired, potassium chloride is deposited on the barrel and parts, which we know well as rock salt, sodium chloride. And salt with a potassium or sodium in combination with moisture and oxygen forms an acid, leading an extremely rapid corrosion of steel, including stainless steel. Western ammo manufacturers have long time ago abandoned corrosive primers, inventing numerous substitutes. And I'm not a AK platform hater, I own one myself. I'm merely analyzing various often propagandistic narratives like those claiming that Soviet Union made the best, most accurate, reliable weapons that could even penetrate rail tracks. So all tests can be biased and adjusted in a way that make one sample look better or worse. And to conclude this section, we can add the factor of powder fooling to the model of finding the best ammunition. However, I don't have the equipment to properly evaluate and compare this. By properly, I mean a study based not on subjective feeling, but on a truly randomized and blind test using a microscope and high-speed camera to create reliability cycle diagrams. So let's focus on comparing and testing what can be accurately verified. Do you see a problem with this batch? What if we scatter them or light them up? Hunter Arms doesn't even pass visual quality control. The most defective round simply wouldn't load into the magazine, while the less defective one loaded but then got stuck. I had to load each round separately as in F-class shooting. This is done because during reloading the bullet is hit shallowly to reduce the jump, ensuring that the almost entire bullet is in the barrel, which prevents the round from being fed from the magazine. Additionally, there have been reports in our shooting community about these rounds. Someone had their upper and lower receiver completely destroyed, likely due to insufficient ignition of low-quality powder during a split-second delay, causing the next bullet to collide with the previous one and blow everything up. So be cautious with untested ammunition and always check that the bullet has actually exited the barrel. Unfortunately, you can tell from the packaging if these rounds will be consistent in terms of accuracy. For instance, I was most impressed with Aguila packaging, but these Mexican tacos are among the least accurate, subjectively on a par with American Remington and Winchester rounds. Interestingly, even not so great Ukrainian Hunter Arms rounds turned out to be more accurate than these. However, we can see that the standard rounds from Lithuania's GG, Czech Cedar Bellet and Swedish Norma don't show phenomenal grouping compared to other standard rounds. A visual inspection of the cartridges revealed no obvious defects, except for some variation in primers in the Remingtons, even within the same box. What surprised me the most was the much great GG rounds with Sierra and Nosser bullets. The round with the Nosser bullet is distinguishable from the one with the Sierra bullet, but the accuracy gap between them is vast. But the gap between the Ukrainian brand STS and what's like the Taliban brand Hunter Arms is even greater. It is also interesting that vendors have complained specifically about STS rounds, and they were even responding to them. They explained this by saying that STS doesn't have a full production cycle, so they just use whatever powder they receive. I also heard negative feedback about STS 9mm round from multiple people. However, I personally had no issues with STS 2-3 rounds, neither in performance nor accuracy. I even bought a new batch from 2024 year for testing purposes, though I already have some from 2022 and 2023 year. But all of this is subjective opinion. I am not forensic or technical expert to evaluate this properly. However, I couldn't ignore this negative feedback from others. It is also important to be confident in your trigger mechanism. For example, I originally bought this trigger for my AR-10, but unfortunately it didn't work consistently. Neither I nor the workshop at Ibis or Tactica couldn't get it work properly. There was one instance where a Winchester round wouldn't fire at all. Not on the first or third try, my light trigger couldn't ignite it. A similar situation occurred with the most expensive, Federal rounds, but that was more likely due to improper trigger function and my shooting stance, as the gas block was set to maximum, resulting in unexpectedly strong recoil. Since the trigger pool is very short, it's resulted in a burst fire. Most likely the firing pin slipped on the bolt. However, on the second attempt the Federal round did ignite. All 748 other rounds worked as expected.
Через дурну стрілянину могли б додому не втрапити.
Let's add this data to the table as well. In conclusion, 15 types of ammunition performed without any issues. I marked Winchester in a light red, Hunter Arms in red, and reloads in bright red, as they never fed a round without the suppressor. Most likely this is due to the gas block not fitting tightly. In the Strike Industries design, the compression is applied from the side, like on the handguard, while the standard gas block is clamped from below, providing the maximum sealing. So if I hadn't changed the gas block, there is a high chance that everything would have worked flawlessly without any issues. And regarding the gas block's performance and tuning in general, it's not an issue to achieve zero recoil by installing an adjustable gas block or replacing the bolt carrier and buffer. Obviously, if there is no impact, there is no extra force to disrupt the entire system. But will it work consistently, reloading with all types of ammunition? What if it gets dirty? What if all these issues occur at once? Reducing recoil isn't the problem. The problem is that you will have to sacrifice something. And it won't pass any military test, especially with military-grade ammunition. Therefore, when replacing the gas block, you need to be confident in your actions, as these interventions affect the operation of cycling the system and the overall performance of the rifle, which is particularly crucial in situations where lives are at stake. It is important to test functionality with all types of ammunition and able to make quick adjustments before going into action. I must note that I have no conflicts or grievances with any specific company, and this is not sponsored review. Moreover, this review might even increase demand and raise prices for the best round, which could end up being detrimental to me, if not financially, then in terms of quality, because increased demand and the inability to scale up could lead to a drop in quality. There is a story about a company that made up much great rounds, but had to increase production volume and speed up due to an order for Vietnam War. The equipment wore out, making it impossible to maintain the same level of quality. By the way, due to wear on the die of the cartridges press, corresponding marketing are applied on the ammo packaging. For example, for 308 Sierra rounds, bullet with OGF length of 1.645 inches are marked at sublot A, fresh die, 0.65 as sublot B, slightly warm die, and so on. Therefore, rounds from different batches will have different point of impact and even accuracy. But let's finally switch to my reliability testing. During the first phase of testing, I found out that 18 types of rounds reliably cycled unlocked back the bolt with the fully open gas block with the muzzle brake, and in the third position of opening with the suppressor. Usually with suppressor you can keep the gas block closed more, because when you attach the suppressor it traps pressure at the front, meaning more pressure will be at the rear. Two other types of rounds, specifically Hunter Arms and my friend's Reload, unfortunately couldn't perform as reliably as the others. They locked back on the bolt catch only once out of 5 times. So I selected the main candidates and compared their performance under conditions of significant undergassing, keeping the rifle in a free recoil state, cause the entire rifle to move in the same direction as the bolt, which also makes feeding the next round more difficult. Even the very reliable AK-47 wasn't initially adopted because if you didn't shoulder it properly, sometimes the cycling system wouldn't work. Using free recoil technique, you can also observe how strong the recoil is with the barrel. Therefore, I conducted the second group without using my phone because there was a high chance it would just break. Plus, I was curious to see how the rifle would cycle once shouldered. I created a plan with the different potential scenarios. First, I shot the different configuration to bring the rifle to working level of dirtiness. And then I deliberately shot in a snake pattern to ensure that the rifle's dirtiness was roughly the same for all rounds during the actual tests. The first configuration was an oversized suppressor with muzzle brake, which I have on my AR-10, as I mentioned in previous section. You can see the paradox. The oversized suppressor, which can generate the pressure that the proper suppressor does, still cycles and even locks back the bolt, unlike the regular suppressor, which didn't even fit around. This is likely because the rifle was completely clean at the start, so there was less resistance in the cycling system materials. A similar situation occurred with the oversized muzzle brake. In my reliability test, you can see that all candidates performed more or less the same. It is clear that 100 rounds might be insufficient for reliability testing, but since I have already fired 600 rounds in the maximum gas block mode, it can be still considered better than nothing. In general, even the best firearms can experience malfunctions. By the way, in cases where a round might have not misfit, I didn't reinsert it for sake of scientific accuracy of the experiment, I only fired them at the end purely for myself.
Als je weer hetzelfde water hebt,